We're now going to enjoy a panel on how electricity can be efficiently used and even partly locally produced at a real estate a building. The first is a film on the House of Choice.
Our world is changing. Our climate is changing. When others are stuck in the past, we plan forward. We proudly present Scandinavia's first zero-energy hotel. This building, with its unique design, will house a hotel with long-stay capacities, offices, restaurants, bars, gyms, and a laundrette, all under the same solar-paneled and sedum-covered roof. With geothermal energy, CO2 air conditioning, and AI, we will give you a building that is completely energy self-sufficient. A building that contributes to biodiversity and life. By efficient planning, we have made every square meter count. Because for the climate, the best square meter is the square meter never built. With this building, we want to inspire our guests and tenants to an environmentally conscious and eco-friendly lifestyle. This is more than a building. This is the new frontier of hotel architecture. This is House of Choice.
So, and in this panel, we miss one of the participants who was supposed to be here, Johan Gerklev from Skanska. He woke up with a temperature this morning and decided he did not want to run the risk of being blamed for infecting us with a new terrible mutation of the virus. So he decided to stay at home. But we do have a qualified panel with Tomas Linderholm, who's the energy specialist of the company ordering this house, Fabege, and we have Anna Graaf, head of sustainability at White Architects, who have been responsible for design, and we have Lars Josefsson of Nexans, who will tell us how the electricity distribution in the building and to the building is important. But Tomas, I think you are now the person who can describe this building in detail and how it came about. The floor is yours.
Thank you. All right, the House of Choice, the Zero Energy Hotel. It's quite difficult to explain what this hotel is in a short while, but just a few numbers. It has 334 hotel rooms, and it also has long stay apartments for, well, environmentally conscious tenants. It is also the main Swedish office for Choice Hotels. It's been environmentally certified for BREEAM, which is an environmental certification system. But if we skip to the next picture, the main thing that people want to hear about when you do these types of explanations is how many solar panels are there? Well, there's 499.6 kilowatts installed capacity on this building. And why is it so close to 500, you think? That's mainly because that's the maximum level you can produce or build without getting taxed in Sweden. So that's an interesting thought. Maybe Anna Werner is a bit interested in getting that ammo for some. So to explain zero energy, we need to be honest about what we have done. We are actually producing more solar energy over a year than we use for the facility to run the building in terms of heating, cooling, and the fans and the necessary lighting. It doesn't take responsibility for all of the electricity because that was simply not possible, but maybe in the future. So this was intended to be a benchmark of what can be done right now. And the project started in 2017, and Choice were very interested in what can we do in terms of an environmentally, well, future-thinking building. And Fabege that's the way we're pronounced. We went in together with them and designed this zero energy concept. And what we wound up is this little building, which is my pride and joy. Before we go into that, what we've done technically is we have an electrified building, as you see. We have a lot of solar panels. We also have a geothermal energy system with a lot of boreholes underneath it, so we can delay our energy use. We can, in a way, thermally store the electricity we produce by using the heat pumps, creating cool during the summer and creating heat during the winter using the sun. So without actually using electrical batteries in this building, which might be in the future, we have found a way to peak shave this building in many different ways. We can discuss that further, but I don't want to take up too much time. And another thing that's very interesting to discuss here is how we actually got away with doing this incredibly demanding goal that we set up. Because getting a zero energy building is vastly more difficult than just constructing a normal building. So what we are quite proud of in this project was that we managed to make a set of requirements in the beginning of the project during the design stage, where it's just a theoretical product. Then when Skanska came in as an entrepreneur, they actually made it feasible and realized this goal, maintaining this is what we're supposed to be doing. And now when we're in the management phase, or when we've commissioned the building, we are actually now realizing it in real life, making the building actually work the way we were supposed to. So keeping this quite extreme ambition throughout the entire process was interesting. But what I think is mainly the biggest, most interesting thing was what we did during the designing the actual building. And that's Anna's department. If you don't want to say something before.
I can immediately hand over. I think what you're describing there is also what was discussed in the earlier session, that the innovation process requires good collaboration between the different parties involved. So,
yeah, thank you. As architects and designers, for creating this low energy building or zero energy building, the design itself, just as Tomas said, is very, very important. So when you sort of draw the first line or on the paper or in the computer today, it's you start with actually what kind of volume can we have? You need to think about the form factor, as it's called, to decrease the ratio of envelope compared to the floor area. Actually, the most energy efficient shape is a sphere. So the globe is probably pretty good in that. And in this case, the site was very good for creating this quite compact building. And then, of course, we think about what kind of materials can you use in this. In this building, it's concrete, but concrete can also store heating and cooling, or heat and cool. But you can also think about, of course, the windows. How big will they be? And that's always a bit tricky, because you need to have maybe smaller windows to keep the energy low, but you want to have larger windows to get the daylight in. But you also need to shade from the sun, because otherwise it's too hot indoors. So it's a sort of combination of these three parameters, and that's usually a quite high challenge in every project. But then we also started with a roof. We wanted to mount these PVs on the roof, and then of course we need to angle the roof in the right way and in the right direction. So that was also very important. And then it's also very high insulated and low cold bridges, and also very airtight building. So what I would like to say is that from a design point of view, of course, it is our most important benefit to this is to decrease the need for heating and cooling and also electricity during the operational phase. But just as Tomas said, the success in this project was this very clear target to have a zero energy building. So because usually you set up a target, but then what was good was that you could work towards the same goal. All of the consultants involved, the technical consultants, the architect, the contractor later on. And it's also very important with the iterative process, the energy calculations and so on during the design phase, because every time you change a window or a material or whatever, it actually changed the energy demand. So so what happened then? Well, we mounted PVs actually in 3 different ways. Usually PVs are mounted on the roof or on the floors, on the facades, but in this case it's on the roof, but also integrated in the atrium, in the window you see on the top here, which also creates, you can see it from indoors, you can see the squared window updoors, but it's pretty nice actually. Then you realize that this is something happening, it's energy efficient. But then in the facade, we actually worked very much with integrating the PVs in the facade as a way of creating an aesthetic that is also, well, it's interesting and it's vibrant and lively, and it changes also depending on the sun and the weather outdoors. So it's actually 3 different types of colors, and it's integrated in the facade in cassettes and so on. And it's also etched. It's like different, it's matte and not glossy, and it's also rilled, so it has a structure, some of the PVs, which also creates a sort of a lively facade, so to say. And actually I was sort of wondering that this matte color and also the shaped PVs, they are actually a bit higher efficiency than just flat PVs. So that's also good to know, because it's reflecting the sun a bit better. So I think that was what I would like to say.
Tomas, when I started teaching at university many years ago, and we discussed energy use in houses, the situation was that the energy needed for building the building was about 10% of the total life cycle energy used. And now when you have reached this zero energy building in operation, then the energy demanded while building the building is suddenly significant. Did you do anything on that part of the construction?
Yes, and that is the perfect question, because that's where we are right now. Because our target was to minimizing the energy efficiency. We were trying to make a benchmark building of how efficient it can be in terms of energy. And that was the main idea. But we, for example, we decreased the slab, the width, in order to minimize the mass of concrete, for example. We had a lot of work on what type of windows and what amount of interior materials we were supposed to use in the building in order to minimize the carbon footprint. But never in this case to the extent that we compromise the zero energy goal. And if I can just get 1 more second about that, is that we now understand that we really need to work on that initial carbon footprint. Everyone needs to put attention to that. Because we are very good at, you said 10%, 90%. This is the life and this was construction. They have shifted.
Oh.
And we really need to focus on what's happening when we produce buildings now. And everyone needs to be honest with where they're called EPDs, environmentally product declarations, that they are transparent and that every product you use in a lot, you need to be really focused on choosing the right stuff.
But what is interesting is that before we spoke only 10 years ago, we spoke about energy, but now we are talking about climate. So that's also why it is a shift, that we actually need to look at the building materials much more.
In the engineering literature, you can find already in the 19th century Swedish engineer Ericsson, who discovered the propeller in the US and became very famous, he wrote on energy efficiency and solar energy, and in his part on energy efficiency, he wrote that a fundamentally important engineering principle, if you want to do something energy efficiently, is that you should have big pipes and small pumps for distributing liquids. And similarly, you do have a choice like that when you design electrical grids. The thinner the cables, the bigger the losses with the same current. I think that is something that Nexans has understood.
Hopefully, yes. So thank you for that introduction. I would like to talk about something which is not on the agenda today. And it's not rocket science, as you mentioned, because it was published 1827 by Georg Ohm. I'm talking about cable sizing and energy losses. Why? Today, installers, describers, contractors using software to find the smallest cables as possible. And technically it works fine. But small cables generate a lot of losses. And that has not been discussed, even if we have the knowledge. So I made an example. I have 2 slides. The slide is, if you take a look at the left, it's just 120 meters of cables. It's not a project. It's a small piece of cables. 150 aluminum cable. Normal load, 1 ampere per square millimeter, so it's not overloaded at all. That is how we do today. Then I took this example, put it into another software. The name is EcoCalculator. It's on internet. It's free of charge. EcoCalculator calculate with a cross-section above the initial one. So what happened? You can see here that the savings for 120 meter is 4,100 kilowatt hour per year. And the return of investment to choose one cross-section above is just 3.7 years. And this is forgotten. So what I did, I scaled up sorry, to 1 kilometer to understand. 1 kilometer, the savings would be in the magnitude of 16 apartments. And then I scale up once again. I was calculating how many meters are installed in Nordics of this kind of cable. It's indoor cables, 4 times 50 to 240. And we could do savings to serve 60,000 apartments by just thinking differently. Do this in 5 years. We serve 300,000 apartments in 30, 40 years.
And this kind of logic you used carefully, or?
No, that's why I'm so interested. It's been a huge thing on in terms of HVAC, like piping and ventilation. We touch on it when we're discussing big cables. But despite this being a zero energy building, it was not at all as focused on as it is on the HVAC side, which I think was a big epiphany when you discussed it. So this is something that we're going to take with us. We touch on it in certain projects, but not at all enough. Yep. So it's a very interesting concept.
It's a typical example of what used to be called the split incentives problem, that the actors who are building the building are not paying the operating costs later. So they minimize the investment and then leave it to the tenants or the customer of the house to pay the running bills. Yeah. But when you had this zero energy ambition, you were actually taking on the long term.
Exactly.
As well. So next time you will not only make a energy net zero building, you will make a positive building maybe.
Yeah, there are several, like as the technological progresses are being made, we could always make this building even more exceptional. Yeah. We are very proud of what it is, and we had a focus on minimizing the energy usage, obviously. But there's if we would have started in 5 years, it would have been something totally different, and that's so inspiring about making these new type of buildings. And hopefully people will take inspiration from this building and build upon it and make something even better.
Yeah, that's good. You're intelligent enough not to believe that you build a perfect building. You can even do better. And now we heard about one lesson learned. You could have been more careful when dimensioning power cables and pipes. Any other interesting lessons you've learned of what you can do better next time?
Well, the biggest thing is that we shouldn't have a 60-meter high neighbor on the south side of a solar paneled hotel.
Very good.
Yes.
Was that a surprise?
No, it was just we had that as a like, this is the lot, and I was initially thinking zero energy on this plot actually. Yes, but then we turned it around. It's the biggest challenge. Putting it there. So that's something, if you want to do it again, maybe put it somewhere else. But apart from that, maybe focus a bit more on, since battery development is fastly taking huge leaps, we should maybe have thought more about storing energy locally in our building.
Yep.
But the good thing about it is that we can actually still do a lot in terms of the slowness of heat flows, since it's so well insulated and so on. We can work with flexibility on the electricity usage. We can also load it with low or high temperatures in order to keep it down. So there's a lot of fun things that we can learn from now as well. So it's very fun to help Choice manage this building as well.
Yeah. So using heat pumps based on deep drilled holes. Do you have any ice storage for cooling in the summer, or is that?
No, we don't have any ice storage, but we have on the ceiling we have this coolant what do you call them? Kylmedelskyler in English. Yeah, you can. And we have these heat pumps who also works. They also work as cooling machines in that case.
Yep.
And the thing is that during summer it's quite interesting because it is a hotel. It uses a lot of heat through its district hot water. So the balance on a day is quite even when you have these geothermal holes.
Yep.
And a lot of the time you don't actually need to use the heat pumps for anything else than making the hot water. The rest of the time they can actually just run.
Yep.
So it's
Anna, similar question to you. What will you do better the next time you get a similar task?
Well, I would focus on reducing the carbon footprint. I mean, this is it's a concrete structure, but it has a lot of wood indoors, the visible materials you have. But I mean, to work even more with a combination, maybe with timber and concrete if necessary. So I would say focus on that, and I know there are some parts that you could work even constructively.
And Lars, you have now advised wisely on how to make a proper life cycle economic analysis before choosing the cabling. Why is this so difficult? I mean, of course, you have an interest in succeeding in giving people the information that so they make a correct analysis. But why is it not done?
Well, first of all, I have a second slide to show because I think the answer will come in that second slide.
Right.
If we can take that. This is touching the panel before because now I'm talking about onshore wind power, and we have been involved in a lot of projects in North Sweden and North Norway as well, and you can say in general that the cable sizing in those projects are so tight. So by having 100 turbines, 2 of those is just serving energy losses, compensating because of tight cable sizing. Unnecessary. And why? Because now it's the why. I think it's about the business model. Because there's an end customer somewhere, like Tomas. You want to make the good building, sustainability, energy savings. Then you have Skanska is not here, but you have a contractor. And if it's not clear, the contractor will choose the cheapest solutions as possible. And here is exactly what is happening. We invest 2 wind turbines, so that is 8 million euro, to save 500K for upgraded net from one cross-section to another one. So I think it's a business model.
No. So again, the split incentive, the wind power company who orders the grid, they don't take losses into account.
Yeah. So now we're heating the ground in the north.
So is Ulrich still here? Yeah, it won't happen again, right? Never, ever. Yeah, good. Okay, thank you. I think it's enjoyable to hear of the example and also of the lessons learned and the process of doing something even better. So thank you very much. We are approaching the end of this event, and I would like to thank you, and I think they deserve an applaud. Huh?